2.
2.
And then what do our x cubed and our x have in common?
X.
Why can't I do x squared?
Because the 4x does not have x squared.
So I have to pick the smallest exponent. Yes?
Mhm.
And then someone mentioned FOIL. So remember, foiling is multiplying it out. We're basically trying to unfoil. So what is the opposite of multiplying? Dividing. So we're basically dividing each of our terms by 2x. So 6x cubed divided by 2x is
3x squared.
okay, and then negative 4x divided by 2x is
-2.
okay. And that would be our answer. Yes?
Yep.
Yeah.
On our second one, what do all of those have in common?
4.
Okay, what else do we notice about it?
The 16 doesn't have.
16 doesn't have an x, so yeah, we can't factor out an x this time. Anything else?
The first term is negative.
Yeah, so what's that called? That number in the front.
Leading coefficient.
Yeah. So our leading coefficient is negative. Usually we'd like for our leading coefficient to be positive. So instead of just factoring out a 4, what might we factor out? Negative 4. And again, dividing that out, we're left with x squared minus 3x plus 4. So now, what type of polynomial do we have there on the inside?
Trinomial.
And it is it a cubic or quartic or a,
It's a
when we have a degree of 2, what's that called?
Square root. Square root.
It is, but what's the function called? A polynomial? No. Alright.
quadratic.
It's a quadratic. Yeah, so we have a quadratic trinomial there. So now we can use that second column in your notes. What is our leading coefficient now for the inside part? 1. So we're just looking at what multiplies together to give us 4, that adds together to give us negative 3. 4 negative 4 negative 3. So negative 4 and 1 would be okay here, but it does not work there, right? Because that would give us negative 4. Are there any two numbers? So our factors of 4 are 1 and 4, or 2 and 2. And the only way for us to add to get something negative and multiply to get something positive is if both of them are negative. So negative 4 and negative 1 give us negative 5, and negative 2 and negative 2 give us negative 4. So there's not any combination. So what is it called when we have a number that only has factors of 1 in itself? Prime. So we can say that this is a prime expression, meaning that we can't factor it any further. Because the instructions on like your homework or on a test are going to say factor completely, which means if I can factor that, I need to take it one step further. But in this case, that is the last step. Okay? Now, on this last one, what do they have in common?
Multiplied by x minus 2.
Yeah. So remember, when we're talking about terms, we're talking about stuff that's being separated by addition. So technically, my x minus 2 times 2x, all of this is my first term. And then the x minus 2 times 3 is my second term. So what do the two terms have in common? They have a common factor of x minus 2. So it doesn't necessarily have to be just like a number or just like one variable. It can be stuff that's grouped together. So then what are we left with? 2x and then a plus 3. Yep. And for that one, that would be our answer. Yes? Questions so far with that? Alright. So, does this one have a greatest common factor? Agreed. Now be careful here. we said that basically we are undoing multiplication, so we're dividing. So what is 3 divided by 3? 1. So we need to make sure we put a 1 here, because a lot of people like think, oh, I'm removing the 3, so like it just goes away and there's nothing left there. But remember, it's kind of like division, so I have to put a 1 there. And then 12 divided by 3 gives us 4. So we would have that. Agreed? A good way to check yourself is also, if I want to, I can go backwards. So if I distribute this 3, I should end up back with this. Versus if I had just put negative 4x squared, we wouldn't have gone back to the same thing. Yes? Now, what type of polynomial do we have inside of our parentheses this time? Mm-hmm. Is it any type of special binomial? It's also quadratic. It is a difference of squares. So notice that 1 and 4 are both perfect squared, because 1 times 1 is 1, 2 times 2 is 4. Okay, so we could actually rewrite this as 1 squared minus 2x squared. Yes? And then we're using that formula that is at the very top on the left. Okay? So my 1 is acting as our A, and our 2x is acting as our B. So our formula tells us that we have A minus B times A plus B. Which part are we confused about? Okay, do you see the formula that I'm talking about using?
No. Oh.
Okay, do you understand where we got the 3 from?
Yeah.
Okay, so not everything. Do you understand that 1 is 1 squared and 4 is 2 squared?
Nope. I don't get where that came.
So like, basically we're trying to work our way backwards, yes? So in order for it to be a perfect square, okay, that means something times itself has to equal this number. And something times itself has to equal this number. Well, 1 times 1 is 1, so I can rewrite that as 1 squared. And then 2 times 2 is 4, so we can rewrite that as 2 squared. And we want to do that because if we can rewrite it as 2 things being squared, we can use that formula that's on your sheet. But for us, instead of an A and a B, we have a 1 where our A is, and a 2x where our B is. So then we just follow the same format. 1 minus 2x, and then 1 plus 2x. So you're just applying the formula. Yes? No? Maybe? Does that help a little bit?
Yep.
Well, we're going to do some more examples with it, so you get to have more break. Yes? Alright, so on this next one, okay, do I still have 2 things that are being squared? Yeah. It's just, again, my x plus 2 is what's being squared this time. So my x plus 2 is acting as my A, and the y is acting as my B. But we can still apply that formula that we have there. It's still going to be A, so x plus 2, minus B, so y, times A, so again, x plus 2, plus B, which again we said is y. Do we all see where we're pulling those from? Alright, looks like most of us are getting there. So, on our first step, my A value here is 4x squared, and here we have a 9 squared. So we're going to get 4x squared minus 9 times 4x squared plus 9. And then Notice that 4 and 9 are still perfect squares. So again, we want to factor completely or as far as possible. So we can actually factor this down to 2x minus 3 times 2x plus 3. But notice that if you look on your front page, underneath difference of squares, what does it say under sum of squares?
No real factor.
Correct. So that second factor, x squared plus 9, can't factor any further. So it just has to stay there. So in this case, we would have 3 factors. Yes?
Yes.
No, maybe? Do we all see where we're getting those numbers from? Okay. Alright, continuing on. What do we have here? Trinomials. So we're moving to that second column, 3 terms. Okay? Now, what is our leading coefficient on our first one?
1.
1. We like those. They make our job a whole lot easier. Okay? Because we're looking at what 2 things multiply to give us 15 that add together to give us 8. 5 and 3. And then the nice thing about our leading coefficients of 1 is that those 2 numbers just get placed with the x's. And those are our factors. We're done. So what's it? We like when we can get our leading coefficient to be 1. Makes it a whole lot easier. Now, what is our leading coefficient on the next one? 3. Can I factor out of 3? No, that would have been nice if we could. Okay, but we can't in this case. So this is where you have to use either, like what the handout calls the rainbow method, or what we call the AC method. So if you prefer AC method, you can scratch that out and put AC method. If you like the rainbow method, then that's fine too. But what we're doing this time is I have to take A, which is 3, multiply it by a -6, which is C, which is why we call it AC, because you're multiplying them together. And we're doing the same thing. So I'm saying what multiplied together gives us, so what's A times C? -18. And then it still has to add together to give us -7. Now, notice technically we did the AC method on the first one. It's just what is 1 times 15? Just 15 still, so like we don't have to change anything. But it does change it when that front number is something other than 1. So what are our 2 numbers?
-9 and 2.
Now, notice if I used the same process as I did here, right? And I wrote x minus 9 times x plus 2. Would that work? Why not?
Because it's positive.
What's positive?
The top one has pluses and the bottom
That's
one has
fine. That part, like you still take whatever your sign is here. So it would still be x minus 3, or sorry, x minus 9 times x plus 2. Can I do it like that? So remember we said, like, if I multiplied myself back out to check it, right? We have to end up with what we started with, correct? And what is x times x? X squared, not 3x squared.
You have to divide the things by 3.
Not quite. Anyone else? So if you
Can we put -9 and 2 for x? So you do -9x and +2x?
correct, so we're gonna replace. So I still have a 3x squared, and basically instead of writing a -7 here, I'm gonna write -9. But notice that we do have an x, so I have to add an x to both of those. All of these steps are also on your handout, okay? And then now, how many terms do we have?
4.
4.
Well, basically 3 because those are like terms. So you can
Well, but if we combine them, then we get back to where we started, right? So that doesn't help us any. So we want to now treat it as 4 because now, if I look in that last column, what is our method when I have 4 terms? by grouping. So now we're going to create two groups to factor from. And you're just looking at the GCF. Okay, so what is our GCF of 3x squared minus 9x?
3x.
Okay, so we're left with x minus 3. And then what's our GCF of our second group?
2.
What kind of 2?
Positive.
Positive 2. So we're also left with x minus.
Couldn't you take out -2, but it'd be more complicated?
You could take out a -2, but the problem is that we need our two parentheses to match up. So like if I took out a -2, we would also need to take out a -3 here in order for our two parentheses to match. Does that make sense? So now, what do they have in common?
X minus 3.
Yeah, so now we can factor that out. And what are we left with?
Minus 3 minus 3x plus 2.
3x plus 2. Okay. Now, this is called the AC method. There's also like a box method out there that does a similar thing.
I think Mr. Kim did that.
Okay. So like if you prefer the box method, that's fine. Okay. When I'm grading your work, I'm mostly just grading is there some sort of work there, you showing me your steps. Okay. When I do stuff on the board, I prefer the AC method just because it works every single time and it's pretty easy to kind of see your steps as you go along. But as long as you're showing correct math steps in your work, like on your homework or on a quiz, that's fine. Okay. And just make sure that I can read your steps because that's important too. Like if I can't follow your thinking because it's scribbled or it's like one step's over here, and the next one's over here, the next one's over here, I get tired of trying. So then I just stop. Okay? Questions on our trinomials? Feel okay so far? Alright, our last kind. Okay, how many terms do we have here? 2. So we're back to binomials. But what's different about this one?
It's cubed.
So which of our formulas are we going to use? Difference of cubes. Now, if you look, so it's that second box on the left-hand side, okay? What do we notice about the two factors from the difference and the sum?
One has a plus, and one has a minus, and one has a plus.
They're both factors. No,
Yeah.
because the other one on the squares you can't factor. So.
Yeah,
You can,
but like, if I look at my factors, so they're both A and B on the first factor, except one is a positive and one's a negative. And then are the second factors similar?
second factor's also be converted.
It cannot. But I just meant like between the two formulas, the difference of cubes and the sum of cubes, is that second parentheses similar?
Yeah, but it's not the same. Because there's a negative and a positive.
So the only thing that's different are the what? The signs are different, okay? So to help us remember our signs, because I think sometimes it can be hard to remember which one goes with which, okay? So we have A cubed and B cubed. Yes? We all okay with that? And then our first one is always A, B. Second one is A squared. And then we have A, B, B squared. Agreed? And that format, A squared, B squared, is the same, whether you have sum or difference. Yes? Then the only thing you have to figure out is your sign. So,
Doesn't the plus on between the A, B, and B also stay the same?
yeah, so that's what I like to remember the abbreviation of SOAP. So S-O-A-P. So S is for the same sign. O is for the opposite sign. And then AP is always positive. Yes? So let's look at what I mean by that. So what is our A value for the problem that we have?
X to the third.
So what's the A value?
X.
X. Okay, what's our B value? 3. Are we all okay with how we found those?
Yes.
Just by taking the cube root basically of both of those. So, using our formula, I have A, which is x, B, which is 3, A squared. So what is x squared? X squared. And then I have AB. So x times 3 gives us 3x. And then b squared, which is 3 squared, gives us 9. Now, what's our original sign? Negative. So that means our first one is the same sign, so it gets a negative. Our second one is opposite, so it gets a positive. And then our last one is always positive. Yes? No? If you just are good at memorizing formulas, then just memorize the formulas. But for me, it's kind of helpful just to remember the SOAP because it helps me remember which sign goes where. Because sometimes that can get a little bit easy to mix up. And just so you know, anytime that you use the cubic formula, this second trinomial will not factor. Okay, so don't waste time trying to figure out if this factors or not. The cubic formula, that trinomial is not going to factor. So this would be my answer. Are we okay with that one? Alright. Let's look at one more. So this one's an addition one. What's our A value for this one? Y. What's our B value? 2. So again, we have A, B, A squared. So we have y, 2, y squared. And then A times B is going to give us 2y. And then b squared gives us 4. Okay? And then this time, what was our original sign? Plus. So we have the same sign, the opposite sign, and it's always positive. That's right. Yes? Alright, I want you to try the last one. Alright, so what's acting as our A this time? X. What's acting as our B? 4. Hopefully we were all able to see that. So what's our first factor going to be? X plus 4. And then our second factor, we have x squared. And then what sign? Minus 4x plus 6. So that would be my answer. Questions on that one? You all see kind of where we're getting those? Yes? No? Maybe? Or why we're using which formulas? That's important too. So it's kind of why I gave you the handout so that you know when I have 2 terms, I'm probably going to use these. When I have 3 terms, I'm probably going to use these. Does that make sense? Sometimes I feel like figuring out which formula to use is the hard part, not necessarily